There wasn't. All right, next part of 1-3. Using the quadratic formula. This is your catch-all. If you are just like, I don't remember any other way of solving a quadratic formula, a quadratic equation, the quadratic formula is your catch-all. It solves all of them. Okay. Quadratic formula. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, so that's your quadratic formula. And it doesn't, nothing special has to happen. You don't have to reduce unless you want to. Like you don't have to, like if, let's say your A, B, C can all be reduced by 2 or something. You don't have to reduce, you don't, unless you want to. So yeah. So underneath your radical in the quadratic formula is called your discriminant. And your discriminant tells you what type of solutions you're gonna have, okay? If your discriminant is positive, so if b squared minus 4ac is positive, then you have 2 real solutions. If b squared minus 4ac equals 0, then you only have 1 real solution. And if b squared minus 4ac is negative, what does that mean? It means imaginary, so no real solutions, right? That's what the theorem is telling you for the formula. Okay. All right. So the steps for the quadratic formula are pretty simple. Identify your A, B, and C. Evaluate the discriminant. If the discriminant is negative, then there's no reason for you to go through the whole process, right? If the discriminant is 0, then you know you're going to have 1 real solution because it's a double root. That means it's going to be a squared factor. So a double root means that you end up with x minus d squared instead of 2 separate binomials, okay? If the discriminant is positive, then you're going to have 2 distinct real solutions. So you have x minus d times x minus e. So you have 2 distinct real solutions. Okay. In all honesty, if you can quickly find the factors by doing what multiplies to give me c and adds to give me b, then do that. If you struggle with that, then quadratic formula. Okay. So again, discriminant, b squared minus 4c, 4ac is what I was referring to. And so here are the rules for you all pretty like. I know I wrote them very sloppy, but here are the rules to pull out. All right, so let's begin. Here, could you solve this by completing the square? Why, yes, you could, but it's gonna get messy because you're gonna end up working with a fraction. And are thirds that nice to work with? No, not really. Could you do X box or grouping? Yes, you could, possibly, if there is a factor of -3 that will give you -4, which is -3 and -1. But then it would make -1, so then no, there isn't a factor. So all else fails. So what do? Quadratic formula. Sorry, I didn't mean to click the button. I meant to write. So step 1 says identify your A and B. So my A equals 3, B equals -4, and C equals -1. Step 2 is to test your discriminant. So your discriminant again is b squared minus 4ac. So I end up with -4 squared minus 4 times 3 times -1. This equals 16 plus 12, which equals 28. So this tells me that I should keep going because I'm going to have 2 real solutions. So now I apply the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. I'd put the a and not the actual 3. I'm hanging on by a thread, guys. All right, so I'm going to clean this up. A negative times a negative is a positive. And we know what's underneath our discriminant. What's under our discriminant? 28 divided by 6. So we did the quadratic. Now we're going to simplify. So now we simplify. And part of simplifying is simplifying your radical. So simplifying the square root of 28. Well, the square root of 28 breaks down to be the square root of 4 times the square root of 7. Yeah. So x equals 4 plus or minus, what's the square root of 4? 2. Does 7 have 1? Nope. Divided by 6. Can I keep simplifying?
Yeah, but no, I guess.
I can. My constants and my are all divisible by 2. So when I divide them all by 2, so divide by 2, divide by 2, divide by 2, and I get 2 plus or minus square root of 7 over 3. This is literally the quadrant. I divided by 2, right? You guys mentioned how sometimes Pearson is picky. Sometimes they'll want the simplified answer. Sometimes they'll want you to split it in 2 answers. So writing 2 plus square root of 7 divided by 3 and writing 2 minus square root of 7 divided by 3. Okay, so pay attention to the little blueprint. That blueprint tells you what it's looking for. And if all else, click view an example, not help me solve, but view an example, and you can see what a final solution is supposed to look like. Because every time you do help me solve, it's going to give you a whole new problem. It's supposed to send me a message. Yeah, if you do, it sends me an email to my MCC account. If you hit message my instructor, it sends me the problem you're on to my email account.
Have you ever seen it? It wasn't working. Yeah, but it didn't work.
Oh no, here we go. All right, I'm back. So when you have a variable in the denominator, main thing is they're going to be the same variable. So your LCD is going to equal the variable with the highest exponent. So what's my LCD here? X squared. So that's your LCD, step 1. Step 2 is to multiply each term by the LCD. So you're going to multiply each term by the LCD. So I'm going to have 7 times x squared minus 4 times x squared divided by x minus 5 times x squared divided by x squared. And is there any real purpose of multiplying anything by 0? No, but I'll write it for the sake of notes. Okay. So I'm going to simplify this. Well, 7 times x squared is just 7x squared. When you are dividing exponents, what are you doing? Subtracting. What's 2 minus 1? X minus 5. And then x squared is going to go away, equals 0. Now it's just a regular problem. Okay, so now I'm going to let you finish it using the quadratic formula.